All right, previously we've dealt with functions of the form f of x equals 1 over x. All right, that was the parent function. Notice there was no x in the numerator though, only the denominator. So we learned about that, but in this lesson, as you can see, we've got x's in the numerator and the denominator. So that's going to change a few things. All right, problem number 1, let's walk through it. For the vertical asymptotes, you find the vertical asymptotes by setting the denominator equal to 0. All right, so in this case, that would mean setting x equals to 0, because that's the denominator, and that's it. So that's the vertical asymptote for this problem, x equals 0. Might as well go ahead and graph that vertical asymptote. All right, it's a vertical line at 0. All right, don't forget to graph it as a dashed line. Now, how about the horizontal asymptote? Well, slow down. Let's talk about this for a second. If you want to talk about the horizontal asymptote, this is a little bit more complicated. The horizontal asymptote is going to depend very much on the degree of the numerator and how that compares to the degree of the denominator. And here's how it breaks down. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. If the degree of the numerator is equal to the degree of the denominator, well, then the horizontal asymptote is just going to be y equals a over c, where a and c are the leading coefficients of the numerator and the denominator, leading coefficients. On the other hand, if the degree of the numerator is greater than the degree of the denominator, there won't be any horizontal asymptote. Sometimes there'll be something called a slant asymptote, but we'll get into that another day. So anytime horizontal asymptote comes up, you have to pause and ask yourself, wait a minute, which one of the three situations am I in? Is the degree of the numerator less? Is it equal? Or is it greater than the denominator? So looking at problem number 1 here, degree. What is the degree of the numerator? The degree of the numerator is 1, all right, because this is just an x. The degree of the denominator is also 1. So that means the degrees are the same. So when the degrees are the same, all right, so we're in the second situation, we'll find the horizontal asymptote by doing y equals a over c, leading coefficient over leading coefficient. So that's why the horizontal asymptote should be y equals, now I've got a leading coefficient of 2, and here I've got a leading coefficient of 1. So that's why the horizontal asymptote is going to be y equals 2. Okay? Make sure you put these letters, by the way. If I ask you for the vertical asymptote, don't just put 0. Put x equals 0. Horizontal asymptote must be y equals 2, not just 2. So go ahead and draw a dashed line at 2 for the horizontal asymptote. Okay, now before we answer the domain and range and that, well, you know, I guess we could answer the domain and range just from this, but I'd feel a lot more comfortable if we went ahead and did the graph first, for goodness sakes. Yeah, I'm gonna go ahead and plot some points now. I'm seeing down here at the bottom, we have our little table of values. Let's go ahead and plot those points now. Now, look, check it out. We will pick the points looking carefully at the vertical asymptote. We're going to need a couple points on the left and a couple points on the right. So let's go ahead and do -2 and -1 and +1 and +2 x values. So okay, so we're going to be doing x values -2, -1, and +1 and +2. And this f of x, you know, these are y values, okay? Okay, so we have 2x minus 1 over x, I do believe. Oh, whoops, I didn't mean to do that. Now I gotta type it in again. Oh well, 2x minus 1 over x. I meant to hit enter. Now it's asking me where I want to start. Remember, we had decided we would start at -2. Let's start at -2. Okay, so at -2 we have 5 halves. Okay, 5 halves is the same thing as 2.5. All right, how about at -1 we've got 3. At +1 we have 1. At 2 we have 3 over 2, which is 1.5. Okay, so let's go ahead and plot these points. So at -2 we've got 2.5. So -2, 2.5 would be right there. At -1 we've got 3, -1 comma 3. All right, so -1 comma 3 would be right there. +1 comma 1 would be right here. And 2 comma 1.5. Okay, 2 and then 1.5. All right, for a simple graph like this, this should be enough points for us to draw the curve. All right, so using the asymptotes, because you know it's going to approach the asymptotes, okay, it should be doing this type of a thing. This is hard to do. Okay, got a little bumpy in there, but you get the idea. And similarly, over here, we're going to approach the asymptote. Okay, we're going to approach the asymptote in this direction as well. Okay, so your graph should look something like that. If you can make it a little straighter, let me see if I can do any better than that last part. Can I do any better? One more try. All right, slightly better. Okay, you get the idea. Now let's finish this. So the domain is the x value. So this goes left and right forever, but it skips over the vertical asymptote, which is at 0. So we're going to go -infinity to 0, union 0 to infinity. That's a clever way of getting everything from -infinity to +infinity except 0. 0 is the one number that's left out of this list. Got to skip that vertical asymptote. Similarly, the range. This function goes down forever and it goes up forever. It hits every point except for a y value of 2. So we're going to do -infinity to 2, union 2 to infinity. Okay, so that's every y value except for 2. Now the y-intercepts. Well, the y-axis is an asymptote, so there will be no y-intercepts. So we'll just put none. Okay, there is an x-intercept though. Okay, so remember your notes. If you want to find the x-intercept, if you have a rational expression, okay, and you have 0 in the numerator, I'm sorry, if you have x in the numerator, then you're going to set the numerator equal to 0. All right, so x-intercepts, you find it by doing numerator equal to 0. That's how you find x-intercepts for these rational functions. So let's do that. Let's set the numerator equal to 0. Okay, so that means I'm talking about 2x minus 1 equaling 0. So I'd clearly add 1 to both sides, so that'll give me 2x equals 1. Then I need to divide by 2. Okay. So that's giving me, why did I put y? That's giving me x equals 1/2. So this is the x-intercept. So it should intercept, and I probably should have found this before I did the graph. but because the x-intercept is right here at a half. All right, so I was slightly off when I did my graph, but it's okay. So x-intercept is 1/2, 0. Now, increasing intervals. Well, as we go from left to right, it is increasing. This whole left branch is increasing. Okay? And so we have an increasing interval from -infinity to 0. Okay, increasing the whole way. But look at the right-hand branch. This is also increasing. All right, again, we had to skip over 0 because 0 is not even part of the domain of the function. 0 is not involved in this. But so really, this function is increasing over its entire domain. Everywhere you go, it's increasing. So the domain and this increasing interval, these are the same. Okay, where is it decreasing? Nowhere. All right, it's not decreasing anywhere. Symmetry. This has neither symmetry. All right, it clearly does not have, it's not even because it doesn't have y-axis symmetry. It's not the same. This is close to being odd, except for the center of rotation is this spot right here, not the origin. So that's not good enough. So neither symmetry. End behavior. As we slide to the left, it approaches 2. Okay, again, see as we go to the left, it levels out and approaches 2. So that's how we will start our end behavior as x I say as x approaches -infinity, the function approaches 2. Okay? Now, as we slide to the right, the function also approaches 2. So I will say as x approaches positive infinity, f of x approaches 2. All right, that's my end behavior. And then these are the points that we graphed. So, nailed it. We're awesome. That's how you do that. Okay, I should stop the video right here before it gets too long. But you know what? I don't feel like dealing with 2 separate videos right now. So, I'm just going to go straight into problem number 2. And you know what? This is going to be a 25-minute video. Whatever. Deal with it. Okay, number 2. Vertical asymptotes. How do we find the vertical asymptotes? We let the denominator equal 0. That's how you find them. Okay, denominator equal to 0 gives you the vertical asymptotes. So in this case, that means, check this out, x squared minus 4 equals 0. Now I could add 4 to both sides and then take the square root. Okay, that's one way to do it. Don't forget your plus or minus. So that gives me x is equal to plus or minus 2. All right, so that's my 2 x-intercepts. But here's another way to do it. I could factor. All right, I could say, oh, what? This is x plus 2 times x minus 2. All right, and the way I solve this is by setting x plus 2 equals 0 and setting x minus 2 equals 0. So that's going to give me x equals -2 and x equals +2. Either way you want to do it, that's how we get the vertical asymptotes. There's 2 of them. X equals -2, x equals +2. Do not leave off the x equals part. So go ahead and graph your 2 vertical asymptotes like this. Okay, -2 and +2. So what's next? Horizontal asymptote. How do we get the horizontal asymptote? Well, remember once again, horizontal asymptote, that's where we have to stop. and ask yourself, which of the three cases are we in? The horizontal asymptote is the complicated one. So, if the degree of the numerator is less, it'll be y equals 0. If the degree of the numerator is equal, we'll do a over c, leading coefficients. If the degree of the numerator is greater, there will be no horizontal asymptote. So we must check. Check on those degrees. And what do you see? Degree 2, degree 2. The degrees are the same. So once again, that means that we will do leading coefficient over leading coefficient. So what are these leading coefficients, you say? Well, in this case, they're both just 1. Clean up over here. So we're doing y equals leading coefficient over leading coefficient. That's 1 over 1. That's why the horizontal asymptote will simply be y equals 1. Do not leave off the y equals part. Okay, so graph your horizontal asymptote. Y equals 1. Always a horizontal line. Okay, domain and range. I prefer to graph some things first before I do domain and range. I'll come back to that. So, y-intercepts and x-intercepts. How do we find the y-intercepts? Remember, to find the y-intercepts, we set the numerator equal to 0. No, that's how we find the x-intercepts. To find the y-intercepts, we simply let x equal 0. Okay, let x equal 0. Okay, to find the x-intercepts, we set the numerator equal to 0. Okay, so y-intercepts, we're going to let x equal 0. So let's see, if we let x equal 0, let's see what happens. Okay, so we're finding the y-intercept. So that would be, if I let x equal 0, that's 0 squared over 0 squared minus 4. Well, 0 squared is just 0. And then so I have 0 over 0 minus 4. Well, that's just 0. So the y-intercept is 0. But unfortunately, that is on my, no it's not. I was thinking of that as my x-axis for a second. No, it's fine. The y-intercept is 0. So let's go ahead and graph that. Okay, that's my y-intercept right there. Okay, so my y-intercept is 0. So in other words, 0, 0. Now, what about x-intercepts? For x-intercepts, I let the numerator equal 0. Okay, so for my x-intercepts, we let the numerator equal to 0. So that would just be x squared equals 0, which gives you x equals 0. In other words, the x-intercept is also 0, 0. All right, which is cool because we already graphed it. All right, so that's the y-intercept and the x-intercept. All right, great. Before we do anything else, increasing, decreasing, symmetry, and all that, let's go ahead and do the actual graph. Now, we're going to need more than 4 points this time. I'm going to need points in each one of these zones. Okay? So look at the zones I'm talking about right now. I'm going to need 2 points in each of the following zones. I'm going to need 2 points over here to the left of this vertical asymptote. I would really like to have 2 points over here, all right, to the left of, like the left side of this intercept. And I'd love to have 2 points over here. Now, it's going to be hard to do, but watch, I'm going to show you how we can do it. And I would also like to have 2 points on the right. So 2, 4, 6, 8. I really would like to have 8 points here in this graph. 2 on the left, 2 on the right, all right, and 4 in the middle, 2 on each side. So let's go for that. Okay, so that's more than I have like space for on my graph, but let's just fill in as many as we can and add in extra spaces later. So let's start over here. Let's do -4 and -3. Well, I guess first we got to type it in the calculator, don't we? Okay, so we have x squared over x squared minus 4. I think I said I wanted to start at what, -4? Let me look again. Yeah, because I want 2 points over here, so -4 and -3 would be good. So let's start at -4. So at -4, I got this. Okay, that's 1.3. So at -4, I've got 1.3. All right, so it'll be like about here. Now, what about -3? At -3, I've got this, which is 1.8. Okay, so 1.8, it's a little bit higher, like that. Okay, that's enough to show me about how this is doing. I'll just hit these points. Okay, do the best you can. Now, I need to know what's going on in here. Obviously, let's do -1. And by the way, every time we do a point, just record it on your table of values here. Okay, so what do we have? We had, so far we did -4, and that was, what? Hello, darling. That was 1.3. And then we had -3, and that was like 1.8. So now I'm about to do I'm about to do -1. Let's see what that is. -1, that's -1/3. Okay, so you know, 0.3. All right, so at -1, I'm at -1/3 of a square. Okay, so let's squeeze in an extra one though. What if we did a decimal? What if we did like -1.5 or -0.5? How about -1.5? How could we do that, you say? Well, hit the table button, all right, hit enter. We can just change where it starts. Okay, I should do this at the end, but I just want to show you. If I let it start at -1.5, all right, hit enter, then that's going to give me what I need. Okay, so at -1.5, I've got -1.3. Okay, so here's -1.5, and that's -1.3. That would be like this. Okay, now I could go back and do the rest. Okay, let's see. Maybe I can tell what +1.5 is if I scroll down. Okay, at +1.5, oh look, it's still -1.3. Okay, so at +1.5, I'm still at -1.3. All right, so I should write down some of these. So I did -1, and then I did -1.5, and I got -1.3. And then I did +1.5, and that's still -1.3. Okay, so just record any points that you're graphing. Okay, I'm betting that +1 is going to be -0.3. I'm going to go back to the table again and change this back to regular numbers. So at positive 1 is negative 1/3. In other words, negative 0.3. Okay, so positive 1 is negative 0.3. Okay, so that'll be, oh, whoops, that's right here. I thought this was the y-axis for a second. So positive 1 is negative 0.3. Okay, so I've got these 5 points in the middle to guide me. So that's enough to show me what's happening here. Okay, using the asymptotes as a guide, and I know it's going to approach these asymptotes, it's going to be doing something like that. Okay, now I need 2 more points. Okay, I need 2 more points. Let's just do 3 and 4. And I'm running out of space here, so I'll just add them on. I'll just add them on right here. Okay, so let's just do add on 3 and 4. At 3, I'm at 9/5, which is 1.8. Okay, so at 3, I'm at 1.8, which is about, oh, you can't see it all the way. So here I am at 3, and this is 1.8. And what about 4? At 4, I'm at 1.3. Okay, so here I am at 4, 1.3 would be right there. Okay, and that is enough to show me what's happening. It's doing something like this. Alright, I'm messing that one up. This is hard to do on a computer, you guys. I wish I could like rotate the paper or something. Okay, that's pretty good. So there's your graph. Now the domain. The domain is everything except for these asymptotes. So the domain, I'm going to do negative infinity to negative 2 to get that branch. Okay, negative infinity to negative 2. Union, and then I've got the middle branch here is negative 2 to positive 2. So negative 2 to 2, union, and then for the third branch it goes positive 2 to infinity. So 2 to infinity. So we have 3 branches, 3 intervals. Now for the range, let me save that. The range, we're going bottom to top. Now, this time I'm not going to go all the way to the asymptote, because look at the top of this branch. It doesn't go any higher than this y-intercept of 0. So this lower branch here is from negative infinity to 0, not all the way to 1. Okay, so that range is negative infinity to 0. And then it picks up from there and goes from 1 to infinity. Oh, you know what? When I just did that range, I made a small mistake just now. I said negative infinity to 0, which is true. But guess what? It reaches 0. So this needs to be a square bracket. All right, it's not an asymptote or anything. It touches 0. 0 is included. But then here, when I do the from 1 to infinity part, I'm back to parenthesis round because it doesn't touch the 1. All right, it's an asymptote. Okay, this is tricky stuff. Now, where is this increasing? All right, well, this first branch is increasing. All right, up, 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 up. So from negative infinity to negative 2 is increasing. Negative infinity to negative 2. That's increasing. Okay? Now, this next little part is also increasing. From negative 2 to 0. Okay? It's increasing from here to here. Okay? So from negative 2 to 0 is also increasing. Okay? I should put a union on that, not a comma. Okay? But then it's decreasing from 0 to 2, it's going downhill now. So that's a decreasing. From 0 to 2 is decreasing. Okay? And then what about this last branch? Oh, downhill like a slide. So from 2 to infinity is decreasing. Okay? So that's your increasing and decreasing. Symmetry. Does this have any kind of symmetry? Yes. This is even, because this does have your y-axis symmetry. So that is even. What about end behavior? As we go to the left, the graph is approaching 1. Okay, so as x approaches negative infinity, f of x approaches 1. As we slide to the right, it approaches 1 as well. So as x approaches infinity, f of x approaches 1. Okay, and that is all the information that we were asked to find, in addition to our lovely graph. So that is it for problem number 2, and that's the end of this lesson. All right, sorry for the long video. I just didn't have time to break it down like I like to. I'll see you on the next video. Hope it was helpful. Guys, if you were copying off of me as you did the video, you need to redo it, okay? You need to make sure you can do these problems by yourself. If you're copying off of me on the homework, when the test comes, you will be clueless and you will fail. So, if you did bad on your last test, that's why. Stop copying off the video. Learn from your mistakes. Peace out.